the next topic that we are going to study today is related to gravitational potential. Gravitational potential is the potential energy stored per unit mass. So if we have 1 kilogram of a mass, how much potential energy is stored of an object, let's say a planet Earth, a moon, or a star, or in the field of any object, how much energy has been stored, potential energy has been stored in it, in 1 kilogram of that material. Potential energy per kg is called gravitational potential, and is minus gm divided by r, where g is the gravitational constant, m is the mass of the object, and r is the distance from the center of the object to that object whose mass we are, or to that point where we are calculating the gravitational potential. Okay, so the question is, find the gravitational potential V at the surface of the Earth. The Earth mass is 5.98 times 10 to the power 24 kilogram, and radius is 6.37 times 10 to the power of 6 meter. Okay, so solution. What we are given here is the mass of Earth. That's our m. And we are also given radius, and we already know g, which is 6.67 times 10 to the power minus 11 Newton meter square per kilogram squared. So V is equal to g m divided by r. G is 6.67 times 10 to the power minus 11. Mass of Earth is 5.98 times 10 to the power 24, and r is 6.37 times 10 to the power 6. And if we solve all these terms, 6.67 times 5.98 divided by 6.37, what do we get? Oh, also we have a negative sign here, because the significance of negative sign is, if we have a planet here, the closer you get to the planet, the energy increases, but in negative sense, that its potential energy is decreasing, like it's lower than zero. So if an object is at infinity, it has zero potential energy. You bring it closer into the gravitational field, its energy start decreasing, the object start emitting energy, so its energy become negative. That's why we have a negative sign with it. So what do we get? If you multiply, minus
6.2 times 10 to the power 7.
Minus 6.3 times 10 to the power 7, and is potential energy per unit mass, so is joule per kilogram. Okay. If you want to find this, potential energy is equal to g m divided by r square. V is potential energy per unit mass, so it becomes g m divided by r square m. M will cancel out, and we get not r square, g m divided by r. So we get this.